All right, today's lesson is actually fairly easy. There's a little bit of math involved, but mostly it's just recognizing different things. We've kind of done this in another chapter where we had angles. We had different types of angles, right? Name some of the different types of angles that we had. Kenny, give me one. Okay, that is a different type of angle, but I heard somebody else. The question probably wasn't worded well. Angela, give me an angle. Obtuse angle. That's a certain type of angles we had. Give me another one. A right angle. Okay. Sarah, give me another one. We had obtuse. We had right. Give me another one. We had acute. Good. What's another angle that we had? Yeah, I'm not really talking about those with parallel lines and transversal, but just an angle itself. Give me another one. Okay, Jesselyn. Congruent angles, yeah, but we had acute, we had obtuse, we had right. There was one more that we had that had to say it. You almost said it. Straight what? Straight angle. It's a straight angle, right? Straight angle is 180 degrees. Yep. Now I'm just talking about those. Okay, so we know those words. We know acute. We know. Somebody tell me what. Emily, tell me what acute means. Acute. Less than 90 degrees. Good. Okay. Gabby, tell me, Smith, tell me what obtuse is. Okay, it's greater than 90. Timmy, tell me what right angle is. It's 90 degrees, okay? Alex, tell me what straight angle is. How many degrees is straight angle? 180 degrees. Good, okay? So we know all those things. We're going to take that and we're going to talk about triangles. Okay, this whole chapter is about triangles, and we're going to talk about different types of triangles. So here's a triangle right here. Oops, if I can grab, it's not that easy. There it is. And let's just make it a little bit bigger like this. Now, if you looked at this triangle right here, look at all the angles. Look at this angle right here. Look at this one here and this one right here. What does it look like to you that's true about all three of those angles?
They're all acute.
They're all acute angles. Very good. Okay, every one of them are less than 90 degrees. Okay, it's kind of obvious, don't you think? Every single one of those is less than 90 degrees. So if you have a triangle, remember this is a whole triangle. If you have a triangle that has all three angles less than 90 degrees, okay, which means they're all acute angles, what do you think we might call this triangle right here? An acute triangle. Very good. Okay, so let's call this an acute, and here's our symbol for triangle. Guess what it looks like? How about that? It's amazing, isn't it? So that's an acute triangle. Now, what must be true about an acute triangle? What? All three angles must be what? Yeah, but instead of saying less than 90 degrees, let's just use the word must be what? Acute. Yeah, you probably talked about this when you were a little kid. They probably did some stuff like this. So an acute triangle is a triangle when all three angles are acute. All three. That's very important, because you can have other triangles with acute angles in them, but it's not an acute triangle. All right, it's only an acute triangle when what? All three angles have got to be acute. Make sense? Good. Let's do another one. Look at this. Here we go. Now look, this triangle right here has got a couple acute angles in it, doesn't it? So is that an acute triangle? No, it's not an acute triangle because what? All three angles are not equal, or not, I'm sorry, didn't mean to say not equal, but are not acute. Look at one of these angles in here. It looks a little different than the other triangle because what?
Obtuse.
That's right. This angle right here is obtuse, isn't it? All right, so if I have just one angle, just one, not all three, just one angle that's an obtuse angle, guess what kind of a triangle I can call this thing? An obtuse triangle, okay? So this would be an obtuse triangle. Now, what's an obtuse triangle? Is it all three angles are obtuse? No, just one. Exactly one. All right, that's important. We'll talk about that here in a second. Exactly one angle is obtuse. All right, exactly one, which means what? Which means no less than one and no what? No more than one, right? Because let's think about it. An obtuse angle is what? discussed this before. Sarah, what's an obtuse angle? An obtuse angle is an angle that's what? Greater than 90 degrees. So let's say, actually, let me see if they've said this yet. I might be stepping over my bounds a little bit. They haven't said that in here, but I think I'm skipping ahead a little bit, but do you mind? You don't mind, do you? You probably learned this before you ever took geometry. If I had these three angles right here, what do all three angles of any triangle add up to be? Andrew? 180 degrees. You probably learned that before, didn't you? Did you ever learn that? Okay, that all three angles of a triangle add up to 180?
Should we write that down?
Sure, write it down. We'll actually have a lesson where we teach that, but I'm just trying to get you to think a little bit right here, okay? So I haven't like officially told you that is true, but you probably already knew that. Most of you did, I think. Who knew that before they came in here, that all the angles are 180 degrees? Okay, good. Now, you're probably taught it. You just probably forget. All right, so so all three angles are 180. So let's think about it. Could I have two angles that are obtuse? Could I make a triangle with two obtuse angles? Alex, tell me why not.
Because, like, I don't know, at my school we did, like, an experiment. We broke up spaghetti to do it, but
Right.
if you're going to have one angle that's obtuse, if you were to try to make another angle obtuse, it's just not possible.
Let's think of the numbers, though. Without even drawing it out, let's think of the numbers. Emily, tell me. That's right, because if I took this angle, which is more than 90, right, and if I had another obtuse angle that was more than 90, what does an angle that's more than 90 plus another angle that's more than 90 have to add up to be? It's got to be greater than what? 180, right? So could I have two angles in a triangle that the two angles are actually more than 180? No, because the three of them have to add up to be exactly 180. So there's no way, is there, that I could have two triangles? And you're right, you could. You could take like little pieces of spaghetti and break them into sizes and things like that, or you could take, little pieces of sticks or something like that that are straight and try to make a triangle with two obtuse angles in it, and you just wouldn't be able to do it. There's no way. All right? Not a triangle. You might be able to get a quadrilateral or something like that, but you couldn't get a triangle to do that. And if you think of the numbers just don't make sense. If this is more than 90 and this is more than 90, those two angles have to be more than 180, and there's no way you can get a triangle like that. Does that make sense? Okay, so that is a obtuse triangle. Let's see, I've got these hidden over here off the side, so let me grab them and just copy and paste. Look at this right here. Now, I haven't told you yet, but take a wild guess what this angle is right here. Yeah, we'll call that a right angle right there. So again, you don't have all three angles being a right angle, do you? You just have one. So if you have a triangle with one right angle, what do you think we're going to call this triangle? Call it a right triangle. We'll just call it a right triangle. Not a right angle triangle, but just a right triangle. So we call it a right triangle. I'll put the symbol for triangle. What's a right triangle? It has what? Exactly one what? Right angle. Okay? So it's got exactly one right angle. Can you have a triangle with, or can you have any triangle with more than one right angle? Again, same kind of reasoning, right? Because if I had one right angle, and if I had another one that's a right angle, where did I put David? Anybody remember? Right over here. Okay. Okay, so I can't have a triangle with two right angles because just those two angles themselves would add up to 180. What about the third angle? I can't have a third angle of 0, right, inside of a triangle. So there's no way I could have two right angles in a right triangle. There is something that's kind of interesting, though. What about, and this would be true with the obtuse as well, what must be true, do you think, about the other two angles? Well, on this obtuse, let's go back to the obtuse. But you're right on what you were going to say, because remember that. We'll go back to that. Okay, yeah, what about these two? They got to be what? They have to be acute. Okay, so an obtuse triangle, one of the angles is obtuse. The other two have to be acute. You got it? Now, look at this. Miriam, I'll give you a chance to say it right here. So if you have a right triangle, what must be true about this angle and this angle? They add up to 90 degrees. Absolutely. Because if this is 90, remember, all three have to add up to what? 180. So that means these two have to add up to 90, because 90 and 90 is 180. Does that make sense? So the other two angles have to add up to 90 degrees. Give me a better geometry word, though, for adding up to 90 degrees. The other two angles, now they don't have to be equal to each other. Complementary, right. They got to be complementary. So let's write it like this. The acute angles of a right triangle are what? Complementary. All right? And that's kind of important to know, I guess. Again, I'm getting ahead of myself a little bit, but let's say that this angle right here was, let's say, 40 degrees. Okay? If this angle is 40, how can I find this one up here? What do you think, Alex? What am I going to do?
You add the right angle and the 40 degrees and then subtract that from 180.
You could do that, and there wouldn't be anything wrong with that. She said take the 90 and the 40, add them up, take it away from 180. Brooke, what do you think? You could, a little bit easier, because you know these two angles are complementary, right? So without even worrying about this 90, you could just do what? 90 minus 40. Wouldn't that be a lot easier math? Yeah, so 90 minus 40 is what? That's 50, so that angle right there would be 50 degrees. Again, I'm getting ahead of myself because we're going to teach that in another lesson, but just thinking about those things. All right? Make sense? So these are all classifying the angles by, or classifying the triangles by their angles. Write that in at the top of this. It's classifying triangles by their angles. So we're just talking about what kind of angles. We haven't talked about the sides at all, have we? So this has all three acute angles, so it's an acute triangle. We're classifying the triangles by their angles. This one right here, we looked at the angles. Again, one obtuse, so it's an obtuse triangle. We looked at this one. It says it's got one right angle, so it's a right triangle. So we're classifying these triangles by their angles, and that's what they're going to say sometimes. They're going to show you a triangle. They're going to say, classify that triangle by its angles. So what are our choices? Acute, what? Obtuse, and right. So those are our three choices. Everybody got that? Okay. Well, we also can classify them another way as well. Actually, I'm sorry. Let's do one more by the angles. I think I got one over here. Let me see. Yeah, it's right there. And let me drop down again. There we go. Now look at this one right here. Now, it looks like an acute triangle, and it is. So all the angles are acute. But it's a little bit more specific than just a plain old acute triangle. I made this before, made it last year, and I made it so all three of those angles are exactly the same. Okay, so if all three angles are exactly the same, we call it an equiangular triangle. Okay? So we got four different ways to classify triangles by their angles. We have acute, obtuse, right, and equiangular. Equiangular happens to be an acute triangle, doesn't it? Because all three angles would be acute. Now again, I'm skipping ahead a little bit, but since we were talking about it before, if all three angles add up to 180, what do you think the measures of all three of these angles actually are, each angle? 60 degrees, right, because 180 divided by 3, you can divide it by 3 because they're all the same, right? So 180 divided by 3 is 60. Good. And that's another lesson, but that's okay. I think it's okay to skip ahead a little bit and think about that. All right, so that's an equiangular triangle. So we've classified these triangles by their angles. Okay, they all had to do with angles. Did we even talk about the sides at all? We didn't talk about the sides whatsoever. So now let's go ahead and do that and classify them by their sides this time. I think I have these already pre-drawn out. Let me just see if I have them. I don't. Maybe. Did I put them over here? No triangles over there. That's okay. I'll just make it myself. Skip all the way down to the bottom. Let me make sure that they will do this. Yeah. In fact, let's do this one. Now, we already said this was equiangular, didn't we? But this is also something kind of interesting. Now, let's take a look at the sides this time. Let's not worry about the angles that much. Let's just take a look at the sides. Look at all three sides. What does it maybe look like to you about all three of these sides? It looks like they're all the same length, okay? And it is, okay? When I drew this, just take my word for it, okay? They are all the same length. Let's make that like this. Watch, put a little tick mark here. We did this before, didn't we? Beginning of the book, little tick marks, okay, to show that those segments are equal to each other. So if I put a mark here, here, and here, what does that say about all three of those sides? It means they're equal to each other. So it's equiangular, because all the angles are equal, but since all the sides are equal to each other, we could also call it equilateral, right? Because lateral means sides. I think we mentioned that in another chapter. Yes, Alex? Yes, it does. It's a good thought.
If it's one, it's always the other.
You're exactly right. Okay, if you have a triangle that's equilateral, that automatically means it's going to be equiangular. And we're gonna kind of discuss why that's true in another lesson, but it's a good observation. Okay, so if it is equilateral, if all the sides are equal on a triangle, that only works with a triangle. Okay, if all the sides are equal on a triangle, all the angles will have to be equal to each other. Again, we'll discuss the whys of that in another lesson, not in this lesson. So now, what are we classifying these triangles by? What now? We're classifying the triangles by their what? By their sides, okay? The other ones were by their angles. These are by the sides. Everybody got that? So equilateral. Lateral means sides. Let's do another type of triangle. And I think I might be able to make this triangle do what I want it to do. Watch this. Boom, like that. Perfect. That's what I wanted. If I could grab that, why doesn't it? There it goes. All right, look at this triangle right here. And let's go to red again. What if I did this? This side right here, I tried to make it pretty obvious. This little side down here on the bottom is not the same length as those other two sides, is it? No. So I don't have all three sides equal to each other. What do I have? I have two sides, okay? So I have two sides equal to each other. So two sides are equal to each other, or congruent, however you want to say it. And what is it, Sarah? That's right, it's isosceles. Isosceles. I looked up isosceles, tried to figure out where it came from. I thought, well, maybe it was named after some guy named Isosceles. You know those old guys, those Greek guys, you know, like, what's that? Yeah, maybe a god or something like that, like a Greek god, or one of these, like Plato, Aristotle. Remember those names, you know? I thought there was a dude named Isosceles running around, but there wasn't, okay? It's the isosceles comes from the Latin, and it talks about two sides being equal to each other, okay? So that's where that comes from, isosceles. So if you have two sides equal to each other, then it's an isosceles, what? Triangle. So again, we're classifying by the sides, the number of sides that it has. If two sides are equal, it's isosceles, yes.
It says that it's
at least.
Sides, would that mean that an equilateral
triangle
is also an isosceles?
Yep, I was going to get to that in just a second. So I said two sides are equal. Most of the time that we learn isosceles, we think, oh, if only two of the sides are equal, then it's isosceles. But if you look, like Alex did, she said the definition says at least two of the sides are equal. So what could we consider this as well? We could consider this isosceles as well, because at least two of the sides are equal. At least means what? Two or more. All right? So I got two or more sides equal here, don't I? So this could be considered isosceles. But I would say most of the time when we're talking about an isosceles triangle, we're talking about a triangle that only has those two sides equal to each other. Okay? There's one more, and we'll quit. One more is if, let me just do this really. Boom. Boom. So let's say that I tried to make this so none of the sides are equal, okay? If none of the sides are equal, no sides are equal, then we call it a scalene triangle. Okay, let me give you some work to do, of course. And it's page 239 and 240. And we are doing 30 to 37.
Cameron Chambers,
and
Cassine
49 to
Hill,
52.
Hannah Mears,
Oops,
Maddie
49,
Smith,
sorry.
report
That's
to the office.
49 to
Cameron
52.
Chambers, Hannah
Okay,
Mears,
30 to 37,
Cassine
49 to
Hill,
52.
Maddie Smith,
All right, that's it.
come to the office.